Okay, let's go ahead and look at this problem where we have some equation that relates h and t, and we want to find out what's t when h equals 27. So we're going to have to use a quadratic, so we will plug in 27 for h, and so we're solving this equation. 27 equals 47t minus 5t squared. So the thing with a quadratic, and when you're using quadratic formula, so if we recall, quadratic formula says the solution to a quadratic is negative b plus or minus square root b squared minus 4ac all over 2a, and that solves the equation ax squared plus bx plus c equals 0. So a couple things about the quadratic formula. One thing, you have to have a zero, has to have a zero on one side. So our equation currently does not satisfy that. And then your a values, whatever's in front of the x squared, or in our case t squared. Our b is whatever's in front of x, or in our case t. And our constant c is whatever is the constant. So the first thing I would do is I want to get everything on one side. Now, the quickest way to get everything on one side is to move the 27 over, but just for simplicity's sake, it's usually better to have this the t squared term be positive. It's not guaranteed, it's not required anyways, but I always like to make it positive, so I'm going to add 5t squared to the left side, and I'm going to subtract 47t. So I'm just kind of moving both of those at once, so this will go away, this will go away. So what that's going to give me is positive 5t squared minus 47t plus 27 now equals 0. So now it's in the form that we have down here. Something squared, something 2 to the first power, and a constant. So the a value is going to be what's in front of the t squared, so that's 5. The b is what's going to be in front of t, so that's negative 47. And the c is what's going to be the constant, and that is 27. So when I plug that into the formula, x equals negative b. So it's the opposite of b. So the b is 47, or negative 47, so the opposite of that would just be positive 47. If it was positive 47 as a b, we take the opposite of that. Plus or minus square root b squared, and this is one of the trickiest things. Make sure you put your b in parentheses when you start evaluating this in your calculator. So negative 47 squared minus 4 times a times c all over 2 times 5. Now how I like to work it, I like to find the discriminant first, so I would just basically put this into my calculator. So I'm literally going to put parentheses 47 squared minus 4 times 5 times 27. And when I do that, I get a value of 1,669. And since these are irrational roots, that's kind of the title of this this problem, my guess is that the square root of 1,669 is not going to be a nice root, but that's okay. And that's going to be over 10. And it's over 10 because obviously 2 times 5. So now we're just going to find these values, and we are going to round to the nearest hundredth. And if you get a negative time, obviously that's not something we want to discuss. But you could certainly get 2 times. If they're both positive, then you would just use both of them. And in this case, I think we will get two roots. So my first one, so I kept writing x, but it's really t, same thing. So this should be t and this should be t, so because they're times. So the first one, I would just type 47 plus square root 1669 over 10. And then my second one, I'll do 47 minus square root 1669 over 10. And the only thing I caution you on is when you put this in the calculator, make sure you put your numerators in parentheses, because anytime you have a sum, it's going to work out better if you put it in parentheses first. So when I put the first one in the calculator, the positive root, 47 plus square root 1669 over 10, I get t equal to 8.785339, and it keeps going and going and going. And it says I want to round this to the nearest hundredth, so the nearest hundredth would be this place here. So the next digit is a 5, so I will round up. So this is going to be at 27 feet at 8.79 seconds. And in this one, when I put the negative root in, this one was also positive. And it turns out to be 0.614660. So at this point, it's 1, and the digit next to it's a 4, so that does not round up. So 0.61 seconds. So this one we'd have two solutions. We'd have this one, and we would have this one. So the idea is, if you think about what this object is doing, it is launching from the ground, going up and then going down. So if you think of where 27 feet is, let's say it's here. Well, so it goes up, and at this first point, it gets up to 27 pretty quickly, and then it kind of continues its path, goes up to the top, and then comes back to the bottom here. Now, if you launch from an initial height, then it is likely that only one of them would happen. If you're launching like from the height, or if you're at the top of a building and you throw something off of it, it's only going to be at certain heights at one point because it's not going to come back up. So that is the general idea behind this one. This is the general idea behind solving a quadratic. So let me know if this helps, and if you need more help, just let me know.